welcome to today's Tech Talk. I'm Kalinga Dissanayake and my colleague Azeem Mumtaz will also take part in this presentation. We are both members of the platforming team, and here during the Tech Talk we'll be looking at a different topic, rather a better way of developing your own API and a tale of a good API, and what are the principles, the design, and what are the things that should go behind, or the things that should be there when producing a good API. So to start off with, what is an API? Any guys answering? Tiago? What an API is? Let's make this a more interactive session so that we can all get involved in. So because we'll be,
it's a medium between two applications can communicate.
A medium.
A medium and even what we call a set of standards.
Set of standards. Anyone else? Okay, so basically, as all of you know, API stands for Application Program Interface. And yes, like Tiago said, it's a medium where components can interact with each other. So let's take into an example. Let's take this diagram as an example. If I press on this red button, right, I will light up the bulb. I will light up the red bulb over there. So if I press the button, the bulb will light up. Think of this as the interface, as the understanding you have with the gadget. That is, you have to press on the button and the button will light up. Right? Take this example into your mind. Right? You have to do something to interact with the gadget. You need an interface, you need a platform to interact with another component. Like Tiago said, the components interact with each other through a platform. So, if you go to the definition of an API, an application program interface specifies how some components, software components, should interact with each other. So again, going back to the example I gave earlier, if you click on the button, you will light up the bulb. So you should know how to interact with each other. The consumer should understand how to interact with the API. So this involves communication between two nodes or applications in order to fulfill a task. And it enables various types of components to integrate and to call each other programmatically. It's basically a doorway through which the right people can pass and get things done. So if I know that this gadget operates this way, if I know that I can press on the red button and the bulb lights up, that means I know how to interact with the API. So just because you have an API also it doesn't make a difference. You should know how to interact with an API. So an API does not necessarily have to be deployed in the cloud. It does not necessarily have to be somewhere remote. It can be within a library. You can call an API with the library. It is any form of interface that you call to get something done, and the clients know how to interact with the component, with the library. So in this presentation, we'll be looking at the tail of a good API. How an API can be created and how it can be developed in such a way that it is better than the rest. The tale of developing a good API. So this diagram, I think you've seen it already. There is so much. If you talk about developing a good API, there is so much to be talked about. There are so many factors, principles, design patterns that can be talked about. But we'll be looking at some of the major stuff in detail so that you guys it will help you guys when developing your programs. And also it will help the QA guys as well to interact with the programmers to understand the code or the code segments better and understand the documentation better. And again, this will not go into detail about a huge complex algorithm or a complex technology. It will go into what you already know and emphasize on what you already know and how you can use these principles and design concepts to come up with a great API. So characteristics of a good API. One, it should be easy to learn, easy to use even without documentation. That is, if you're given a library and if you have a method, save merchant, you should know by looking at the name that it will save a merchant. It cannot do anything other than saving information. Hard to misuse. That is to practically force you to do the right thing. For instance, you might be able to call an interface and do something which actually the API does not intend to do. That should not be the case. A good API should not allow that. A good API should practically force you to do the right thing. Easy to read and maintain code that uses the API. Once you publish the API, this is very important. Once you send an API, maybe if you deploy it in a remote location or if you publish a library, it should be easy to read as well as it should be easy to maintain, and it should be powerful to satisfy all the requirements. That is, just because if an API is embedded into a library or deployed elsewhere, but if it does not carry out the intended task, there is no use of doing it. And it should be extensible, and there are people who write on it and put changes so that it can evolve with the later changes, and it should be adequate and appropriate. So these are some of the points we listed down that should be there in a good API. So let's move on. So we talked about what an API is. We talked about what a good API is. What are the characteristics that should be there in a good API, and what makes a good API different from a normal or a day-to-day API you use. How you make your API a good one, a better one. So the next question I would like to ask you is, with all the stuff I have told you, are you an API designer? Is a PHP programmer an API designer? Is Ananda an API designer? With the stuff I told you already.
Yes.
Why do you say that?
Let's say you mean in the point of implementing another API using PHP application, or
No, it may be that, right? It may be that. Or you might be creating a library which your colleague can use. It is basically interface. For instance, Prabodh might use your API. It is basically an interface where you can get things done. So yes, how does that, this has basically come through modularization, right? So let's say I need to develop a huge functionalities. Maybe I need to develop a complete merchant related functionality. I have to do save, updates and all that. What we do is we modularize the code. We make sure that we put the code into different modules or different libraries, and we call these libraries. Those are the interfaces, those are the APIs that we utilize. So basically every coder, almost every coder, every week creates an API and it is utilized by the clients. The client might be elsewhere, might be all around the globe, or client might be the next person who is sitting next to you. So always you should make sure that the API is designed properly and implemented properly, and it turns out to be a good API. So yes, let's look at the example again. Let's look at the definition in the Wikipedia. Many times an API comes in the form of a library that includes specifications, data structures, object classes and variables. In some other cases, notably for SOAP and REST services, an API just comes with a specification of remote call. So it can either be a library, it can live in a library, or it can be deployed elsewhere in a remote location where you can call the API. So yes, that means every one of you, when you code, you should make sure, you should give the focus, you should make sure that you come up with a good API, come up with a good interface where your clients can interact with each other. So how does the API design help with the company? Good API design will result or will encourage the company to exceed. For instance, if you deploy a good API, for instance, if we advertise, or once when we get our platforming APIs done, and if we deploy it in a remote location, if the APIs turn out to be good, that means it will benefit the company. However, if the APIs turn out to be bad, it's going to be a total wreck. For instance, if you deploy an API, if you expose an interface in a library and you put it in our archiver, and there are clients all around using that particular library, we won't be able to change it. So bad APIs will definitely be distributed, whereas good APIs will encourage the company and result in it may change the life of a company. So moving on, when designing the API, when designing interfaces for clients to utilize, there are several things we thought we should come up with. One is filter requirements. when you start designing an API, designing an interface where all the clients could interact with you, you will get tons of requirements. For instance, the product manager at Leapset will come up with a hell of a lot of requirements, what he wants to do, what should happen, an ideal job should execute, things like that. What you should do is filter out these requirements. You should understand the proposed versus actual requirement. For instance, there was a recent requirement saying that the Leapset code or the Leapset code base should interact with the Salesforce. However, the product team came up with various stuff, suggested various implementations as well. However, we should be able to identify the implementation and what the exact requirement is. We should be able to filter out the actual requirements from the proposed. So if we identify the requirement, although the requirement may be specific, when designing an API, it might be advantageous to build something more general. For instance, if you are going to create an API to save a Synco merchant in your database, it ideally does not have to save Synco merchants only. If the API designer, if we feel that there will be other types of merchants in the future, it could be a more abstract version. It could be a save merchant instead of a save Synco merchant. So yes, one, you should identify the requirements properly, distinguish between the actual and the proposed requirements, and if the requirement is even specific, you might have to go through the requirements again and to see and decide on the approach you should take when designing and implementing the API. So again, the next step, another step would be to start with another design point you can focus on is to start with small specification. Say I have to implement something and I come up with 100 to 200 page specification. It's not going to work. It might not even, for instance, the product manager might come up with a requirement, but eventually it might not even be delivered to the customers, to the production environment. So first we should come up with a small spec, identify what needs to be done, and then develop on it and work on it as the work progresses. You should think of the components involved in the initial design stages so that you know all the components affected and so on. Another point in the design is maintaining realistic expectations. You should not over-constrain the API. You should not overburden it. The API should carry out only the task intended by the API. For instance, a save merchant or a save tip API should not do other functions that are not interrelated or not related to it. So, and another key point is, if you look at all the requirements, like I said earlier, you should filter out the requirements, right? But therefore, you won't be able to satisfy all the requirements. For instance, I won't be able to satisfy Diago here and Gavin there as well, both together. So we should filter out the requirements and make sure that the expectations of the API or the interface that you are exposing to the client are realistic. So, and of course we need to expect a few mistakes, right? We can't be perfect with the approach. So yes, at the design phase, we should maintain the realistic expectations and make sure it evolves and it corrects itself while we progress on. So another thing is we should design the API early and often. We should come up with the API interface and understand the client that is calling us should understand the interface that should be provided to the API. And the first lines of code become the base of your API. Therefore, it's very important before starting the coding or before starting implementation or before going into implementation details, you should understand what the client requires and what you're planning to expose to the clients. So the interface of the API or the way the clients communicate with the API should be clearly designed and should be identified before progressing to implementation. So we looked at some of the API design stuff we should look into. Let's look at some of the principles that we should focus on. One is an API should do one thing and do it well. It should not do several things at once. For instance, if you look at this example, it gives an update merchant method. This is a real-time example in our coding actually. So in this update merchant method, we do several things. But actually the interface exposed to the client is update merchant with the flag is merchant updated. Right? But there are tons of things done here. If you look at it, it updates the merchant queue consumers. Then it updates PayPal properties. Then it updates again, it dispatches some message to a queue. and it updates and it sends an alert email. So the name of the method is update merchant, but it does 4 other things. It never updates the merchant. So one general principle you should focus on when designing an API or when coming up with an API is to do one thing and do it really well. Remember, it's a warning sign if you cannot name an API. For instance, in this case, you cannot name this. It does all sorts of things. So it's a warning sign if you can't name it. If you can't name your interface, it's a warning sign since you do all sorts of things that you should not do. Moving on, again, another point would be to remove anything unnecessary. Optimization is good. It is good. But we should focus on the performance issues as well. For instance, an API exists in production. Maybe it's exposed via remote API calls. Just optimizing it won't help. If the performance is degraded by optimizing the code, maybe let's say we do some SONA fixes, maybe there are some changes. The quality of the code should be improved. Just because you improve the quality of code, it does not really add value if you break the performance or if you degrade the performance. So we should focus on these even before exposing, because for instance things like, say we provide an interface in a library and we deploy it somewhere else and it is used by several clients, that particular version is used by several clients, we won't be able to change it easily. So we should focus on these as well. Another key point is it should be customary, that is it should coexist with the platform. For instance, let's say in the case of PHP, there are various conventions that are being used. We should write on these, we should start developing APIs on this. You should be customary. We should not do anything that is totally different to the PHP world. This normally happens. For instance, this happened to me as well. When I moved for a short period for a PHP project, and I really did not have a clue until about two months back. The conventions are a bit different. The basics are true, but there are some things that are different. For instance, if you look at the Symfony framework and if you look at Spring, there are two totally different stuff. The naming conventions, the way they approach, the way they are deployed is totally different. So whatever you do, it should coexist with the platform you use. So again, the other basic, we talk about this every day and we reiterate so that people do this, right? Documentation. Documentation really matters. For instance, during the last 2 months, we've been really focused on, as a platforming team, during the last 5 to 6 months, possibly, we have really focused on it. We have done documentation previously, but then during the last few months, we have focused on it really a lot. So, why is documentation really important? Say, I do not know what you are doing. Say, you're a developer, and I do not know what you are doing. I can be a new starter to the team. I can join the team new. I can be the person that has joined the team yesterday. What I need to know? I need to know how the components interact, what are the components involved, what are the functionalities involved, how it is to be deployed. That is what I need to do. In the case of I do not know what you are doing, I can be also project manager. Someone like Tiago or someone like Gary. Then what happens? Then that person should understand at least understand how the components interact, how it is brought, how the web interface is loaded, things like that. So the key point there is you should understand the audience. You should understand the audience who reads the documentation and provide or cater the requirement properly or appropriately. You should provide the documentation that satisfies the needs of the audience. Another key point is, yes, I might not know what you are doing. You also might not know what you are doing. So another key point is why documentation matters is you might know you might not know what you are doing. You might be just coding or interfacing or providing interfaces for clients, but you will not have a clue about what's happening. So that's another point. When you start up the documentation, when you write up, you understand how it interacts with each other, how components interact, and it gives you better visibility to what you are actually doing. Another key point is document religiously. Every class, method, interface, constructor, parameter, exception, just document it. This is a nice saying by Parnas. What he's saying is, doing it requires both good design. What he refers to is reuse. Reusing requires both good design and very good documentation. Even when we see good design, which is still infrequent, we won't see the components reused without documentation. So what he says is, even if we if we spend hours in API design and we come up with a good design, there is no point if we don't have a documentation. It has to be with documentation. It has to be supported by good, viable documentation so that the audience understands what an API does and how the client should interact with the API. So again, it should not be, I mentioned this previously as well, it should not be a huge spec, it should be selective. And you should let the code do the detailed what. You should allow the code to do the detailed what. Instead, in the case of a document, you should give a high level what. You should not go into detail saying how this is going, what methods are being used, what are the technologies that are being used. It depends on your audience, yes. So that's one of the main reasons why we have the documentation is very important, and the audience should be identified before putting your documentation in place. So normally a document, a design document, a document that helps the product managers or the different various sorts of audiences should focus on the high level what and why. Moving on, there are, again I've emphasized, when you document in practice, several things you can focus on. One is ask some questions. What I should do, what I should document, what are the components involved, how do I do this? Is it pictorial or diagrammatic, or how do I approach this? Or do I use, what sort of medium will I use? Then who is it for? The audience is the key. I've been focusing on it a bit. Managers, the engineers, the QA clients, or the other stakeholders. It might be a client elsewhere. It might be someone who uses your API interface elsewhere in somewhere else, not in this country, somewhere else. So you should focus on the audience and come up with a good documentation. And when and why will they be used? That's another key point. Is it a temporary design document for a patch release? Or is it a document that's going to be there throughout the system for a couple of years? So you should focus on that. If it's a patch release, then it should be done in such a way that it includes only the information about the patch, not information about how it's implemented and so on. And if it's going to be maintained for 2 years, it should be done in a way that it is scalable, and you can change the documentation as you proceed with your design and implementation. And another key point is how long will it live for, and when will they use it and why. Another key point in API design and API implementation is testing. Again, you should hit your API as soon as possible. Once you expose it, you should hit it as soon as possible. This will allow you to test your API before allowing access to all sorts of third parties or exposing it to library. You should hit your API as soon as possible to identify any issues that come up. And then you should continuously hit your API. This is to avoid any last minute mishaps. For instance, if you just start testing, and if you have unit test cases that you utilize daily, but after the first phase or second phase, you stop using it. You do not continuously unit test your code. Then it's going to have problems. When you put your fix into the next release, or when you push it to the production, you might have last minute mishap. So to prevent that, you should hit your API as soon as possible, and you should continuously hit your API in order to avoid last minute mishaps. Then again, test driven development. We've talked about, I think we had a couple of sessions on this already. Write your test before you write your code. Write the test cases so that you know what you expect what the API or the interface or the library that should do. So when you write your test case before you code, that allows you to understand the mistakes better, understand the context better, and understand the points of failure, points of success, and what the API should do. And this will, if you continue to if you use the TDD principles and continue to hit your API and continuously hit your API, this should enable you to minimize your issues as much as possible. And you can use various other tools such as Sona to improve quality and coverage and stuff like that. So yes, what I mentioned was what an API is. What is an API? It doesn't have to be a remote API where it's deployed somewhere in a server. It can be any interface where the client knows how to do it. So if there's, like the example I told you earlier, if you have a gadget and if there's a button on it, and if you press on the button and if the bulb lights up, and if you know that pressing on the button will light up the button, that can be illustrated as an example of an API. That is, you provide an interface and the client knows how to call it. The client knows the way to interact with that particular gadget. that exactly is an API. So it is the API when you come up with its design is important as well as implementation details. Let's look at some of the other things. We'll be going into several other things that come up with it. There are several well-known principles that have been introduced by various well-known authors when that will be very useful when creating your API successfully and making sure that your API is a good API. Azeem will continue with the other principles.
Okay, thank you, Kalinga. So let's move a step further. So far what we looked was the really abstract level, the design level, the principle levels. Okay, so from now onwards, what we are going to look is the implementation level. So bear in mind, I'm going to use Java as an example to explain certain principles. So this could apply to any other languages. So any other, doesn't have to be Java, can be PHP or any other dynamic language, other than static data languages, etc. So in my session, I'm going to divide into 3 sections. The first one is I'm going to talk about how the designing better classes. And in the second section, I'm going to talk the way to design better methods. And in the third section, I'm going to talk about the exceptions. Okay, so designing a better class. So the first principle is minimizing the mutability. So mutability talk about the principle of the quality of being changeable. So it's changing the state. So those are mutability. So what does this principle tell us is classes should be immutable unless there's a good reason to be mutable. So for the APIs, from the API perspective, what APIs which we provide should more into be immutable. So you may ask a question, why we should do this? So if it is mutable, then the user of the API will get a lot of flexibility, a lot of control over that. But as you see, that great power comes with great responsibility. So the API may be misused by the client. So that's why we should minimize the mutability. And also, of course, this will reduce the flexibility of the API as well. So there are many ways to make a class immutable. So few of those are avoid mutators. So mutators are the behaviors that changes the state, and using final private fields, controlling access to mutable states, constants. So these are other approaches that enforces the mutability. And there could be a situation where you really need mutability. So for that you could use mutable companions. So I'll show you an example. So here you could see there's a class called account. I'm sure you can't see it, but this is account class. So this account class has a state. It's a big decimal balance. And it's a constructor. There's a constructor, so this will construct the account object with a minimum balance. And also there's another method called withdraw. So what this withdraw will do is it will reduce the balance. Simple as that. So here if you see, when we withdraw the money from this account, it will always create a new instance of that account. So original object, the state of the original object will never change. So that is immutability. So the client, the thread will get a new object with the balance of the new balance. So here, however, this class can be extended. This another class can be a subclass of this account. So to avoid that, we can use final. So this class will be 100% immutable. So in case of the mutable companions, so I just added more methods in this account class. So if you see, there is another 2 extra methods. The first one is get mutable account. So what get mutable account will do is it will return a mutable version of this account. So we create another class called mutable account. So the reason for that mutable class is to provide a way or an approach, a companion to this class, this account class. So we can change the state. So the reason was, suppose this transaction is a complex operation and there are hundreds of, more than, let's say, more considerable number of codes in this. So first what we could do is, suppose there's account 1, amount 1, amount 2, and there's some complex operation going on here. So first I will get the mutable account with the existing balance. So this will return the mutable account with the existing balance, and I do all the operation with that mutable account. So, okay, so and then once the operations are done, I again create an instance of this class and return it. So this account object, the state of the account is never changed, and for the complex transactions, what we did was we introduced a companion, and that companion is a mutable. And once the transaction of complex operation is completed, we return the immutable instance of account. So one of the disadvantages of immutability is that for every state change, there is a new object created. So for situation like this, we create a mutable companion and reduce the number of objects created. So the second principle related to designing better class is Liskow's substitution principle. So basically this talks about the subclassing or the inheritance. So the inheritance is a principle of creating substitution based from another class. So basically we derive classes. So derive, what does this tell is derive class. So the next one, a good example was the array list, because array list extends the collection. Why? Because list is also a type of a collection, a different type of a collection. So we should use substitution only when there is a relationship, not as a relationship. Other than that, you could use compositions. Third principle was design inheritance principle. So what does this principle tell us is design and document for inheritance or else prohibit it. So that was told by Joshua Block. So basically the APIs are written by expert for non-expert, and this subclassing, the inheritance, actually violates the encapsulation. Why is that? So let's suppose there's an API. So I'm an API user, I'm going to use that API, and I see there is a particular method which I could overwrite. So if the API is not designed inheritance, what does that mean is the user does not know what would be the impact if I override that particular method. So if I override that method, the overall behavior may change, because that particular method, the method which I'm overriding may be dependent, may use some other methods to fulfill its behavior. So there's a chance when you override, the whole behavior may break. So there are some policies. So first we need to find what are the methods relates to other methods, and this should be documented. And all concrete class should be final, because if it is concrete from the API perspective, then that class can't be extended. So for example, the very famous example is the Joda API, which almost every, or maybe every API's classes are final. So some other example, if you take from the JDK, hash map. Hash map is not a concrete class. You can extend extend hash map, and if you override particular method, there is a high chance that it will not work. Hash map, the hashing algorithm may mess up. There's a higher chance that it will mess up. So the good examples are the abstract test, abstract sets, abstract map, because those are documented for inheritance. So specifically designed and documented so that it can be subclassed. So the next principle was don't make the client do anything the API could do. So what does that mean? So I'll go through this example. It's a very simple example. It uses a W3C DOM API. So basic idea is there is an XML, and that XML needs to be printed in an output stream. Simple as that. So to do that, there are these two are the needed imports. We import from the W3C DOM API and the Java IO. And if you take these three, transform API, transform DOM API, and the transform stream API also need to be imported for some reason. And here, first we create the transform object, and then transform object is created through some factory, and the properties are set to that transformer, and then finally we transform the XML into the output stream. So if you see this is called boilerplate code. That means this can be used elsewhere, and it's repeatable, and also this introduces higher chance for new bugs and defects, because client can mess up. Client can set different properties, different output properties. So this principle tells that. This principle tells that the API should handle these things. Why? Because there's a simple use case. Client should print the XML. So the whole overall idea here is, when you're designing the API, especially the class, you need to think of in terms of use cases. What does the client want? What does the user of the API wants? What he's trying to achieve from this API. So that's the overall idea. So the next principle was the principle of least astonishment. So what does this do? Tells is the API, the users of the API should not be surprised, should not get surprised by the behavior of the API. Suppose there's a method, and that method should not have or minimum side effects. So if I pass a method or variable, and if I pass the same variable next time, and I should get same result. So there should be no surprises. So for example, if you take this thread, so you know in Java, thread implements the runnable state, and there's a particular method called interrupter, that a static method that returns the boolean. So from the users of the API perspective, what he will think or she will think is that, okay, I need to check whether this particular current thread is interrupted or not. That's it. But this API does one more extra thing, that is highlighted in red color. So it clears the interrupted state of the current thread. The user expected that only it will return the status, whether it's interrupted or not. That's it. But the API does something more. So we should avoid these things. So these are the polar situations. So the next principle is fail fast principle. So if there is an exceptional situation in the code, that in the API, so the client, the users of the API should immediately know what's the issue. So if you remember, there in 1970s or 60s, there was a incident related to the Mariner 1 satellite. So the mission control got to know about a bug in the code after 5 minutes of takeoff. And because of that delay, the satellite got crashed. So what is the issue? Simple thing, there is a missing hyphen in the code. As in one place there was a missing hyphen. So this principle is called the forgive principle, because the code, there was a bug, but that bug was not immediately communicated to the users of the API or the client immediately. It got like after 5 minutes only, the mission control got to know about this bug. So this is a bad practice. So we need to fail fast. So the best approach to fail fast is at the compiler time. So I'm sure, I think this the language written in Mariner 1 could be a dynamic programming language. So if it is statically typed, you will know, okay, at compile time there was an exception, there was this missing hyphen. So Java in that case, it's a statically typed, and at compile time you will know, okay, there's this hyphen is missing. So fail fast approach leads to a very reliable and robust design of APIs. So the other principle was overload with care. So we should avoid any ambiguity in overloading step. For example, if you take tree set, this is a tree set from the JDK. So there are two constructors in tree set. First one takes a collection, and the other one takes a sorted set. So sorted set anyway is a collection. Okay. So when you construct a tree set with a sorted set, this constructor will be invoked. If you cast that to something other, let's say array list, for example, that's also mentioned. So this tree set will be invoked. So in that case, for example, let's come back to that. Let's see. Let's say I'm passing a sorted set, and I cast that to a collection, and I pass to the this constructor, and this first one will be called. So the point is there is an ambiguity here. So I'm passing the same object, and in first scenario I'm passing it as it is. In second scenario I'm passing it as I'm casting that to the collection, and I'm passing that. So in these two scenarios, the output, the state of the object should be same, or else there is going to be an ambiguity in the code. So that's the point here. So there should be some other mechanism. So in the first construct, it should say, okay, if it is a sorted set, if the collection is an instance of a sorted set, then invoke this constructor. Maybe something like that. So these are some of the very well-known principles. So we should always program to an interface, not to an implementation. So this will give flexibility, performance, scalability, etc. And we should use specific possible input parameters. Sometimes because from the API perspective, it will be more error prone because client relies on the third-party code. So client should know, okay, what exactly the parameters need to be passed in order to use the behavior. And another point is that we should avoid using string, because for the client, he does not know most of the time what to do with the string if you return a string. So we need to return appropriate data types. And the other point is to avoid using floating, floats, double for the monetary values. Why? Because it will result in not exact computation. So because of the precisions, so the output may change. And in case if you want to use float, then go for the double, because the precision loss is real and performance loss is negligible in double than the float. So another point is that we should use consistent parameters ordering across the methods when you are writing the API. So as an API developer, so suppose there is two methods. First one is equal, and the second method is not equal. Assume that. And in first method, it takes two arguments. Both are string, and the first argument is expected argument, so the variable name is expected, and the other one is actual. And this is swapped in the other method. So this is a bad practice. Why? Because API user will get confused, because for the first time he use this equals method and passing the first parameter as expected, and when there's a chance that he may miss when he's invoking the second method, he may pass expected into the actual place. So we need to avoid, we need to be very careful about the ordering. So if you take JDK, in JDK there is a collections class. So it's ordered, all the collections methods are ordered in a proper way. The first variable, first parameters are always a collection, and the second one is something, a string or anything else. So the other point is you should avoid long parameter list. It's obvious from the users, API users point of view, or the developer's point of view. When he's using your API, he should remember what are the parameters passing, which he should pass to the API. So if it is more than, the ideal thing is it should not be more than 3. So less than 4 is the ideal parameter type. So the basic idea is API user should not get confused. So some of you already have come up to a method behavior in a particular API that takes a lot of parameters. So in that case, what you could do is break up the method, or else you could use build a pattern. So what it does is it incrementally builds the object the client requires. So it's very clean. So finally, exception designs. So for the exceptions, this is related to the fail fast also. And from the API perspective, you should favor unchecked exceptions, because there should not be any compilation or the runtime, the compile time exception. So all compile time exceptions should be handled within the API itself. So other than that, based on the input of the user, so the behavior may change. So at that moment, there could be any one-time issues. So those, because of that, from the API point of view, the unchecked exceptions are preferred. And also the exception should be more informative. There should be documentation logs if an issue occurred, so that developers or the users of the API can use to debug. And yeah, basically you should follow a message oriented concept. Like for example, you should give the code to a particular issue. So that depends on the way you design the API. It also depends on the requirement. So that's it, the topic.